All right. Okay, welcome back, my NextGen family. Okay, we are going to go through October, November 2024, paper 1-3. Okay, so this is a 80 marks paper. So I will tell you all which one we don't use calculator, okay, for the sake of practicing for your new paper 1. All right, please ask me if you all got anything, and let's go. Okay, let's look at question number 1. Okay, this one I will put this under paper 1. Okay, whatever that I put as paper 1, you all do it without calculator. Find the coordinates of the stationary point. Y equals to x plus 3, x minus 4. Okay, what is stationary point? Okay, the meaning of stationary point means dy over dx equals to 0. However, this question you can do another alternative way also, because this is a quadratic equation. Your stationary point will be your maximum point, minimum point, which is your midpoint of the roots. Okay, but you all have already learned differentiation, so just use differentiation. I think will be much easier here. Okay, let's open up the bracket first. Let's write this down. Y equals to x plus 3 times x minus 4, x squared minus 4x plus 3x minus 12. X squared minus x minus 12. Okay, we want to do dy over dx equals to 0. So let's find dy over dx first. So we use power law, 2x minus 1. Okay, dy over dx equals to 0. Therefore, 2x minus 1 equals to 0. X equals to 1 over 2. Okay, easy. Okay, then we're going to sub in 1 over 2 into y. So y, okay, which equation should we use? Okay, we just use this one, x squared minus x minus 12. So 1 over 2 squared minus 1 over 2 minus 12. Okay, we'll get here 1 over 4 minus 1 over 2 minus 12 minus 1 over 4 minus 12. Okay, 4 times 12 will be 48. So minus 1 minus 48, we get minus 49 over 4. Okay, so just try your best to always do these type of questions without calculator. Okay, your final one, you don't leave it like this. You write it in bracket form. 1 over 2 minus 49 over 4. Okay, just to be safe. Okay, one more tip, right? I want to highlight to you all. Some of you, because it's very hard for the marker to see where is your answer if you all write it somewhere in the middle. So if you want to present your presentation, you all do it like how you all answer mathematics. You all know your mathematics, normally at the bottom right, there's a space for you all to fill up the answer, right? You answer it like that. So if you all do until here, okay, you see one of the answer is here, one of the answer is here, just rewrite the final answer again. Okay, if you want to just make sure that the marker see your answer. Okay, that's just a small tip, because sometimes, like even for myself, when I mark students' paper, I cannot find your answers, right? Okay, because either you're writing too messy, okay, or sometimes maybe I'm tired already. Very hard for me to find the answer. Okay, this question 1A. Okay, question 1B. Sketch the graph of y equals to modulus x plus 3, x minus 4, stating the intercept with the axis. Okay, first of all, we need to follow the acronym SIM. SIM means we want to determine what is the shape first. Okay, so S, how does the shape look like? So original shape for a quadratic, this is a positive ax squared. So this is a happy face. Then when you modulus, it'll become like this. Okay, I want you all to also bend it correctly. Okay, it's like a W shape like that. I represents your intercept. Okay, let's find what is the x-intercept and y-intercept. And when we do our calculation, don't do with the modulus first. So I want you all just do like this first. Because we want to sketch the original graph, then only we reflect it up. X-intercept, y equals to 0. So x plus 3, x minus 4 equals to 0, x equals to negative 3, x is equals to 4. Y-intercept, x equals to 0. Okay, we can use the other equation, which is x squared minus x minus 12. So here is y equals to minus 12. Okay, the last one, m is your maximum or minimum point. For this, we already calculated in the previous one, okay, which is equals to 1 over 2 minus 49 over 4. Okay, let's do a rough estimate. So here, 1, 2, you can use your ruler to measure. 4, okay, here, 1, 2, 3. Okay, we have here minus 3 and positive 4. Okay, your points, put as x, like that. Okay, then we want to do another 2 more, which is your negative 12 and the turning point. Okay, you do this rough sketch somewhere at the side first. Okay, or if you want to do, you draw light lah. Okay, but normally I would say just draw it somewhere at the side. I'm showing all just showing all the process here. Okay, so we'll do like this first. Okay, let me see, what's these 2 points? Negative 12. 1 over 2, negative 49 over 4. The y-axis, I just roughly estimate. Okay, then now we want to reflect both of these points go up. Okay, so this will become... Yeah, drawing green color. Oh. Okay, like this. Label this. Here need to label 12. Okay, they never asked us to label this, but we can label lah. Okay, so here is 1 over 2 and 1 over 2 and 49 over 4. Okay, few things to just take note on this, which I see still a lot of students make mistake, is how you all draw the graph. This bend, please don't do like that. Okay, this is wrong. Okay, it's originally a U shape. Okay, a trick. If let's say in exam you're really not sure, okay, how to do it, right? So you try to draw it like a almost a straight line like that. You pandai lah. Okay, this is if you are not sure, but that is still you're sure lah. Okay, draw the original graph so it's bending like that. Another thing, please don't put the turning point at the y-axis here. Okay, I see a lot of students always force to put it over here. It can be, but you check where is the turning point. Normally, if they never ask you to find the turning point also, it'll be in between the two roots. Okay, that means your 2-point intersection. The moment you put your turning point over here, they minus your mark already. Okay, the entire shape will be wrong. Okay, the next question, question C, given that k more than 0, write down the values of k for which the equation of this modulus x plus 3 x minus 4 equals to k has exactly 2 distinct roots. Okay, where is exactly 2 distinct roots? Okay, Jordan say, yeah, okay, your explanation is absolutely correct. Okay, they say this thing here, okay, what is k? K is y. Okay, y equals to k because this is a y equation. Y is equals to y. So what are we finding here is when we draw a horizontal line, okay, where exactly will we get 2 points of intersection? Okay, supposedly is here and above the turning point, right? But because of this statement here, k is more than 0. So this one, we don't take it. Okay, this one is also 2 solution. So what is this section here? This one will be k more than the y value, 49/4. Okay, anything above here is all 2 points of intersection. At the turning point, it is 3 points of intersection. In between 0 and 49/4 is 4 points of intersection, or 4 distinct real roots. So the only answer that we want for this question is k more than 49/4. All right, please type 1 if you can understand this. Okay, do we need to draw the dotted line in exam? Don't need. Okay, don't need. But if you leave it there, I don't think they will minus your mark, but just don't draw it until so dark lah, because it's not part, it's actually not part of the final answer. You can draw light, okay, and make sure you all use pencil to draw. Okay, the rest of you, are you okay? Please type 1 if you all are okay. Okay, I see all the 1, 1, 1. Okay, good. All right, let's move on to question 2. Okay, question 2. Can we do this without calculator? What do y'all think? On the axis, sketch the graph of y equals to 4 plus 5 sine theta over 2 for negative 360 to 360 degrees. State the intercept with the y-axis. Okay, can do or not? Without calculator. What do y'all think? Okay, cannot. Okay, I want you to think hard for this one, because just in case it comes out in paper 1. Okay, actually can. Okay, so this is something to highlight on. If you use calculator, okay, we do calculator way first. So I teach you all, if let's say come out in paper 2, please just use calculator. Okay, everyone just create a table out first. Okay, we create a simple table out. Okay, we got minus 360, minus 180, 0, 180, and 360 degrees. Okay, I want you all to type in the value here. Okay, 4 plus 5 sine theta over 2. 4 plus 5 sine, okay, I put on my calculator, x over 2. Okay, make sure it's in degree mode first. So minus 360, we'll get 4. Minus 180, we'll get minus 1. 0, 4, 180, 9, and last one, 360, this one, 4. Okay. So let's see what's this scale. 2, 4, 6, 8. Okay, 2, 4, 6, 8, 10. So here will be, I just label down here. 2, 4, 6, 8, 10, negative 2, negative 4, 6, negative 8. Okay, first one, we've got 4, negative 1. 0 is back to 4. 180 is 9. 360 is 4. Okay, we should roughly know the general shape first. This is a sine graph, so you should get S shape. like this. Okay, one thing to know here also, if you all have done some of the questions, you realize that even when you use calculator, you see, how come when I feed in all these values here, the value keep giving me 0, 0, 0, 0, 0, 0, like this. Okay, so if that happens, what you need to do is you make your intervals smaller, meaning you go and put here minus 270. Okay, put all the in-betweens, right? Minus 90, 90, 270. All right, sometimes it's not labeled here, so you need to put smaller. If that value also still cannot, then you divide by 2 some more, meaning you put maybe of intervals of 45, 0, 45, 90, 135, 180, 225, 270. Okay, that's a tip. Okay, so this is if you got calculator, please don't waste time, go do mental calculation. But let's say you don't have calculator. Can we do this? Okay, so this was something that I've been highlighting in this series of paper, is that we need to know our special angles. Okay, what are our special angles? Which is 30, 45, 60. Okay, 30, 45, 60, and you need to know all your values of the original one also. Okay, so let's see what are the values over here first. I just want to focus on this value here. Sine theta over 2. Okay, let's create this table out. Sine theta over 2. Okay, if our theta is equals to, okay, we do the, let's I'll explain to you all using the positive one first. Sine 0. Okay, sine 0 over 2. Can or not? Oh, sorry, let me simplify this. 0. Okay, what is sine 0? We should know that it is equals to, okay, everyone, 0, right? Because this one, we follow the original graph, like this. Your sine graph, you need to know. Okay, sine 0 is 0. Then, if your x is 180, okay, so here now is 90, right? Okay, 90, where is 90? 0, 90, 180, here is 270, here is 360. Okay, so this part here, sine 180 divided by 2, okay, will be sine 90, which is equals to 1. Then, if your value is 360, so it's follow 360 divided by 2, which is sine 180, which is 0 here. Okay? So this one, we don't even need special angle. But if special angle come out, you all should know how to do that also. Okay, so do the same thing for the negative one. So we have here minus 180 minus 360. Okay, what's sine minus 180 divided by 2? So sine negative 90 will be equals to negative 1. Okay, so this one you all follow this graph here. Like this, then like this. Okay, here is negative 90, then negative 180. Okay, so minus 360 will follow minus 180, which is equals to 0. All right, so you all just refer to this original graph. Then you all calculate 4 plus 5 sine, okay, y equals to 4 plus 5 sine theta over 2. Okay, so what is this y value? This one will be 4 plus 5 times 0. So this one will be 4. Okay, this is based on the official graph. 4, 5 times, 4 plus 5 times negative 5 minus 1, 4, 9, and 4. Okay, so just base it on the original graph. Okay, this is quite an easy 4-mark question. So I think Okay, I think this one this one might come out in paper one. So y'all be ready. Special angles and angles comparing with the original graph. Okay, you use different method. Okay, what different method that you are using? Anyone use any other different ways? Amplitude and period, okay? Also can? Also can. Okay, very good also. So that means you draw according to understanding amplitude, period, and vertical translation, right? Also can. 360 over B, yeah? Mm. Okay, good. Okay, good, Jordan. Yep. Okay, number 2, any question? If all good, can you type 2 in the chat? All right. See all the 2s. Good, good, good. All right, let's move on to question 3. Find the values of k for which the question 4x squared minus k equals to 4kx minus 2 has no real roots. Okay, this one, paper 1. Easy question. Yeah, no real roots means b squared minus 4ac less than 0. So we first rearrange the equation to ax squared plus bx plus c first. So 4x squared minus 4kx. Okay, this one I will put the 2 first plus 2 minus k. Okay, put it like this. So we've got a, b, and c here. A is 4, B is negative 4, K, C is 2 minus K. Okay, then here we're going to put into B squared minus 4AC less than 0. Minus 4K squared minus 4AC less than 0. Okay, we open up 16k squared minus 16, 2 minus k less than 0. 16k squared. Okay, this will be minus 32 plus 16k less than 0. Okay, we divide the whole thing by 16. This will be k squared plus k minus 2 less than 0. Okay, we'll get here k plus 2, k minus 1. These are the critical values. Then we'll draw this out. Okay, this one don't need to draw, but we just draw it so we can answer the question. Okay, we got k equals to minus 2 and k equals to 1. So minus 2, 1, less than 0 means this bottom part here. Okay, so our final answer will be in between minus 2 and 1. Okay, this part here is called quadratic inequalities. Okay, what has real roots? Okay. So there's one special one that has come up before. Okay, what do y'all think is if they change this question to has real roots? Do y'all remember? Has real roots. 2 and negative 1. Why 2 and negative 1? K minus 1 equals to 0. So k equals to 1. K plus 2 equals to 0. So k equals to negative 2. Okay. Anyone knows what's the statement here? Has real roots. If I change the question, find the values of k for this equation which has real roots. Okay, more than 0. Okay, everyone agree? Is it more than 0? Okay, more than equals 0. Okay, very good, Chloe. Okay, so I want you to remember this. We've got two different sentences. Actually, got four, so got a total of 4 statements. One has two distinct real roots. Okay, so you write this down. Two distinct real roots or two different real roots. This is more than 0. Okay. Second one, two equal real roots equals to 0. No real roots less than 0 has real roots. Has real roots is a combination of the first and the second one, which is b squared minus 4ac more than equals to 0. Not more than 0. One distinct real root, no such thing. Okay, there's no such thing as one distinct. Distinct means different. How can you have one different real root? That means it's equal real root already. One equal real roots. Has real roots cannot use more than 0. No, cannot. If they just say has real roots, it's either distinct or equal. So it's a combination of the first two statements. Yes, more than or equal. More than, then wrong already. So more than is when you see distinct or they say two different real roots. Okay, so one has distinct, one is just real roots. Didn't know that. Okay, yeah, now you all know. Okay, so write this down, all of these little things. All right, number 3. Didn't know the last one. Okay, very good. Number 3, if you can do this, okay, type 3. There's no lesser than equal. There's only four of this statement here. There's no such thing as lesser than or equal. Okay, just follow this 4. Okay, distinct means different. Okay, so like how you distinct, two different things are distinct to each other. Means you got two different types. Okay, number 4. Okay, so say for the real roots, how do we format the value? K equals to 1. You just add a equal here. Here, like that. How do we format the value of k? So is it k equals to 1? How do you mean k equals 1? It's the same, okay, it's the same exact way. Oh, sorry. This is less than 0. If it's more than 0, then k less than equals -2, then k more than or equals to 1. Okay, remember how to do this one? It will be above the graph. Okay, don't worry. Later today's class, we'll go through all of these questions. Okay, this is under your chapter 4. Okay, this question here. Okay, question number 4. Write 3 plus 4 log 2a minus log 2b as a single base 2 logarithm. Okay, first thing, we make all of them to base 2. Okay, there's no base over here, so 3 can write it as 3 log 2. It's log 2a minus log 2b. Okay, bring the power up. Log 2a4 minus log 2b. If it's plus, we will multiply it. So log 2 cubed will be 8a4. Okay, minus means you divide by b. So log 8a to the power of 4 over b. Okay, next one. Solve the equation. Log x equals to 4 log x 10. Okay, LG means log base 10. So we change either both to log base 10 or log base x. Okay, I'll change the log x10 to log base 10. So when we want to change between the argument and the base, okay, that means these two values, we can do the inverse of it. So log x10 can be written as 1 over log 10x. Okay, log 10x, which is 1 over LG x. Okay, so LG is log 10. So log x equals to 4 multiply 1 over log x. Okay, we're going to multiply both sides by log x. So this will become log x, the whole thing squared. Okay, this one you need to put as a bracket. If you don't put as bracket, you'll be wrong already. Okay, cannot be log x squared, must be log x bracket squared. It's two different things. Okay, why is it two different things? If you don't put the bracket, some of you will bring it in front here. Okay, that is where we normally get wrong. Okay, cannot bring it in front. This one, your square, you have to plus minus square root to the right hand side. So plus minus square root 4. So log x equals to plus minus 2. Okay, we're going to do from this index form, or we call it exponential form, to log form. So here become 10. We can put x equals to 10 to the power of 2, or x equals to 10 to the power of negative 2. X is 100. X is 1 over 100. Okay, so make a highlight here. Log x squared is not the same as log x squared. Log x bracket square is different as log x squared. Okay, number 4. This one, paper 1. Can do without calculator. Okay, please type 4. So normally the first half of the paper, please try your best or your practice do without calculator right now. Okay, let's move on to number 5. Okay, number 5 can do without calculator also. Okay, so let's put this as paper 1. Okay, come. Screenshot this. Okay, factors and polynomials. This is your chapter 3. The polynomial p is such that px equals to ax cubed plus bx squared minus 19x plus c. A, B, C are integers. Is given x plus 2 is a factor of px. When px divided by 1, x plus 1, the remainder is 20. Okay, show that 7a minus 3b equals to 39. So we have to use the concept of factor theorem and remainder theorem. First one, it is a factor. So x plus 2 is a factor, means we substitute p negative 2 is equals to 0. Okay, x plus 2 equals to 0. So we substitute it in. So a negative 2 cubed plus b negative 2 square minus 19 times negative 2 plus c equals to 0. Minus 8a plus 4b plus 38 plus c equals to 0. Okay, this will be our first equation. The second equation, okay, they say divided by x plus 1. So p minus 1 will be equals to 20. Okay, this is remainder theorem. So we substitute in a negative 1 cubed plus b negative 1 square minus 19 minus 1 plus c equals to 20. Minus a plus b plus 19 plus c equals to 20. Okay, we look at the equation that they want us to do? Okay, they want us to write it as A and B, meaning we want to get rid of the C. We want to eliminate the C. Okay, this is good because both of the equation we have just C only, we can just do elimination. Okay, maybe we simplify this first. Minus A plus B minus 39 plus C equals to 0. Okay, sorry. In fact, I should be bringing the value out. Plus C equals to 20 minus 19, which is 1. Okay, this one also I just bring up. Plus 4B plus C equals to minus 38. Okay, we've got these two equations. We also want to make A as positive. Okay, let's call this equation 1, equation 2. Okay, I'll take equation 2 minus equation 1. Okay, let's subtract all of this. Minus 1 minus A minus 8A, so it will be plus. This will be 7A minus 3B. C minus C will be 0. 1 minus minus 38, so 1 plus 38 will be 39. Okay, shown. And right here. Okay, question B. It is also given that P prime X is divided by X minus 1. The remainder is 1. Find the values of A, B, and C. Okay, P prime X means your first derivative of P. Okay, Px. Okay, what is Px first? Ax cubed plus bx squared minus 19x plus c. Okay, let's differentiate that. So P prime X will be equals to 3ax squared plus 2bx minus 19. Okay, divided by x minus 1 means P prime 1 is equals to 1. Okay, so we get 3a 1 square plus 2b times 1 minus 19 equals to 1. 3a plus 2b. Okay, the 19, I'll bring it to the right-hand side, so equals to 20. Okay, 3a plus 2b equals to 20. We want to find a, b, and c, so we have another equation from the previous one. Okay, let's call this equation okay, this one was equation 3 lah, okay, the one that we found just now. So let's call this equation 4. Okay, we bring equation 3 down. So 7a, oops, sorry, cannot yet. Okay, so got equation 3, equation 4 here, right? Okay, so we need to do simultaneous equation. Okay, let's do an elimination. Okay, so I'll take equation 3 multiply by 2. Okay, this will be 14a minus 6b equals to 78. Then I'll take equation 4 multiplied by 3. Here will be 9a plus 6b equals to 60. Okay, we do elimination. Both of them add up together. Okay, this one will be equals to 14 plus 9, which is 23a equals to 138. A is 138 divided by 23. We should get A is equals to 6. Okay, let's find another one. So we have this one value. We substitute A into, okay, just choose either one of the equation. I'll choose to equation 4. Okay, so sub A equals to 6 into 4. 3 times 6 plus 2b equals to 20. 18 plus 2b equals to 20. 2b equals to 2. B is equals to 1. Okay, and the final one. Okay, we got A, B. Now let's choose which one is the easiest equation. Okay, got any easy equation? Sub into B equals to 1. Okay, actually doesn't matter. Sorry, it matters. We want to find C. Okay, substitute into. Okay, I will choose this one. Okay, minus A plus B plus C equals to 1. So sub A and B into 2. Okay, so here will be minus 6 plus 1 plus C equals to 1. Okay, our final answer, C is equals to 6. A, B, C. Okay, number 5. Can do, please type 5. Can we do different way, but same answer? Can, no problem. Okay, so your simultaneous equation, the equation that you all use might be a little bit different. You do substitution also can. No problem at all. Okay, let's go. The next one, question number 6. Okay, this one, you all need calculator. Okay, so this one will come out in paper 2. Won't come out in paper 1. The table shows variables x and y, which are related by y equals to ab to the power of x squared, where a and b are constants. Okay, use the data to draw a straight line graph of ln y against x squared. So we need to change all the x value to x squared and ln y first. So everyone take out your calculator. Okay, create another 2 layers down here. X squared and ln y. Okay, so 1 square, 1. 1.5 square, 2.25. 4, 6.25, 9. Okay, then ln all the y values. We will get here 2.64, 3.51, 4.72, 6.28, and 8.18. All right, now let's plot it out over here. Okay, let's see what's the scale over here. This one is 1. Okay, 5 boxes, 1 over here. So, okay, this is what I normally would write first. So you determine what's the scale first. So 5 box is equals to 1. 1 box is equals to 0.2. Yeah, can. If you want to do the 1 decimal place also can. But the later the calculation actually can lah. But I normally write it to 3SF because just to follow the format. Here is 10 box equals to 1. So 1 box equals to 0.1. Okay, so you all do your define your scale first. Okay, when we plot it out, then definitely it's you use to one decimal place already because here cannot draw it so accurate. Okay, so first one, 2.64. Okay, so we do 2.6. 2.6 will be here. Okay, one trick I teach you all draw your x a bit fatter. Okay, so when you all draw the graph that time, at least it looks like can go through all the points. Okay, if possible. All right, don't put a dot. Okay, try not to put a dot because the dot, later when you check back, you don't know where's your point also. Okay, when you draw your line already, you cannot check back. Okay, 2.25. I will round it up to about 2.3 and 3.5. Okay, where's 2.3? 2.3. 3.5. Okay, so around here. Next one. 4.72. Okay, around 4.7. 6.25. So let's do it about 6.3. 6.3, 6.3. Here, then the last one, 9, 8.18, so around 8.2. Okay, plot all these points, draw your best fit line, okay? See whether can pass through or not. Okay, according to mine, can. Beautiful. Okay, what are the main question normally for this drawing one? Always the same format. They'll ask you find M, ask you to find C, okay, your y-intercept. So let's look at the next question. Use your graph to estimate the value of A and B. Okay, the A and B is normally from your x-intercept, your y-intercept and your gradient. We go back to the equation first. Y equals to AB to the power of x squared. Okay, I want you all to change into the format where your y is ln y and your x is x squared. Okay, how do we do that? We will change it to ln both sides first. Okay, so ln y equals to ln AB power x squared. Okay, we want to make it into y equals mx plus c format. So we're going to separate this ln A plus ln B x squared. Okay, this we can bring it down. X squared ln B. Okay, we want to make it to y equals mx plus c. So here will be ln A equals to ln B. Okay, this one, make sure you put a bracket like that. X squared plus ln A. Okay, don't put it as ln B x squared immediately. Sometimes you may confuse yourself because if you don't put the bracket, the x squared, it may seem that it belongs to the ln also, but it doesn't. Okay, it's two different terms. It's ln B times x squared. Or to be more specific, actually, it's x squared ln B. Okay, so this is in the format right now of y equals mx plus c. They want us to find what is the A and B value. Oops, why got 2 ln A? Sorry, this is ln y. Thanks, Jordan. Okay, ln y. Okay, so what is A and B? B, ln B is your gradient. Okay, so we want to find what is the value of the gradient. So ln B equals to gradient. Okay, we just write as M. Everyone understand what's M, right? So M, or we can write ln B is equals to, okay, let's take 2 points. Since all the graph pass through all the points, okay, what I like to do is I will take the last point and the first point. Okay, the coordinates of the last point, which is 9, 8.18. The first point is 1 and 2.64. All right, so we'll do y2 minus y1. So 8.18. 0.18 minus 2.64 over 9 minus 1. Okay, calculate this. 8.18 minus 2.64 divided by 8. 0.6925. Therefore, B, okay, ln, we inverse the ln will become E. So you need to know your knowledge on log also over here. Okay, so put E 0.6985. You get 1.9987. Where we round it up to 2 because they want one significant figure. Okay, the next one. Ln A. So according to my graph, okay, you go back to your graph, you see where is your point of intersection for here. Okay, according to mine is at 1.9. Okay, so C is equals to 1.9. You all just follow your own graph. So ln A equals to C. C is 1.9. Therefore, A is e to the power of 1.9. Here will be 6.685. Therefore, your final answer should be 7. Okay, so whatever value that you all get, even if your graph is slightly different, your final answer to one significant figure should be 2 and 7. Okay, it should not go so often. B equals to 2, A equals to 7. Okay, the last one. Use your graph to estimate the value of x when y equals to 200. Give your answer correct to 2SF. So here, if y equals to 200, according to the graph, it will be ln 200. Okay, so the value that we want to read from the graph is at 5.3. Okay, so when y equals to 5.3, so we go to the graph. Okay, find your 5.3 here. 5.3, so will be over here. You go here and this point. Okay, according to mine is at 4.8. Okay, at 4.8. So I think you can put 4.8 or 4.9. We calculate this. The the x value will be x squared. So x squared is equals to 4.8. X, we only take the positive one, square root 4.8. Okay, we'll get 2.19. Or your final answer, we write it as 2.2. Okay, they allow 2.1 to 2.3 also for this last question. Why the graph we use C equals to 1.9? What do you mean why? Why do we do that? Because we want to find what is the y-intercept. The C value is y-intercept. You see, ln A represents C. You thought it starts at 1. No. They didn't say that the range or the domain is from 1, right? They just say those are the points that are given to you. So you need to extend your entire graph until you find the y-intercept. I get you understand. They never say the domain. It's just the table of values. So you have to extend all the way, okay, to find this value. Got it, Aurelia? Okay, if you can do this, can you type 6 in chat? Okay, so 1 to 5, no calculator. Question 6, can use calculator. All right, awesome. Okay, we'll pause here first, and then I'll continue in the next section.